just going down these list of variables. Let's click on neighbor. You remember where we defined neighbors before. Neighbors was, what was neighbors? It was a what? It was an agent array. It was an array of agents. By the way, we could have treated it as an array of cells, and then we wouldn't have to do that cast every time. But, okay, but here what we're doing is, for this startup code, basically for the cell, when a cell comes into existence, what it does is it grabs its list of neighbors and saves it away. So when a cell comes into existence, it takes its neighbors, calls this get neighbor. That's just built into AnyLogic, get neighbors, and it stores it away because it won't change over time, as it says. It just stores it away for future reference, so it doesn't have to call this every time. So that's a performance thing. So then you run the model, and this is what it gives. So that's the code which is running behind the scenes. This is the core of it. This determines whether the cell next time step is alive based on its value, its current time step, and how many things are around it.
Could you do it in continuous time?
Yes, you could. Yeah, you could. But it wouldn't yield the same results exactly. One thing I should emphasize about this is deterministic. There's no stochastics here at all, right? No stochastics. If you did in continuous time, you'd have to be asking, okay, what leads one cell to update before another cell? Is that stochastic? Is it possible I could update twice in the same period of time where one of my neighbors doesn't update at all? And then there'd be stochastics introduced. And one of the beauties of this current thing is that it is totally deterministic, okay? So maybe what we'll do is we'll break for, can we keep it to 5 minutes? And then we'll talk about mobility. Because all we've been talking about right now is embedding. Now I want to talk about mobility. How do these agents move around? How do they carry themselves between cells? Okay? And we'll see that in just a minute here. Okay? So maybe we can come back in 5 minutes or so. And we'll go on to that.
So what's the theory says